Hi everyone, today we are going to study some terms related to a graph. First of all, we'll see the incidence and degree of a graph. So, what is incidence and degree of a graph? When a vertex Vi is an end vertex of some edge Ej, Vi and Ej are said to be incident with each other. So, you know an edge has two end vertices. So, when a vertex is an end vertex of some edge, then that vertex and that particular edge are said to be incident with each other. And in a simple language, if I tell you, whenever a vertex is associated with an edge, or whenever an edge is associated with a pair of vertices, then those vertices and that edge are said to be incident on each other. For example, here if we see a graph with 5 vertices and 7 edges, so you can clearly see that vertex V3 is associated with edge E6. Or in other words, vertex V3 is an end vertex of edge E6. Hence, I can say that V3 and E6 are incident with each other. Similarly, V4 is an end vertex of E6. So, I can say that V4 and E6 are incident with each other. So, this is the concept of incidence. Two non-parallel edges are said to be adjacent if they are incident on a common vertex. Now, what are adjacent edges? So, any two non-parallel edges. So, keep in mind that we have to exclude parallel edges from this concept. We cannot consider two parallel edges to be adjacent to each other. Other than that, any two non-parallel edges are said to be adjacent with each other if they are incident on a common vertex. That is, if both the edges which are non-parallel have a common vertex associated with them, then those two non-parallel edges are said to be adjacent to each other. For example, the edge E2 and E7. If I look at the figure above, then the edge E2 and E7 can be thought of as adjacent edges because they have a common vertex V4 between them. Similarly, E2 and E6 can also be called adjacent edges because they have a common vertex V4 with them. So, this is the concept of adjacent edges. Now, let's see the degree of a vertex. The degree of a vertex means the number of edges that are incident on a vertex Vi, or in other words, the number of edges that are associated with a vertex Vi, where Vi represents any random vertex. It can be vertex V1, V2, V3. So, for any vertex, the number of edges that are incident on that vertex with self loop counted twice. Right, self loop is counted twice and rest of the edges are counted once. So, the number of edges incident on a vertex with self loop counted twice is called the degree of the vertex. It is denoted as dVi for vertex Vi. That means if you have to calculate the degree for vertex V1, it will be denoted as dV1. If you have to find the degree for vertex V2, it will be denoted as dV2. Now let's find out the degree of the vertices given in the graph below. Here we can see that the degree of vertex V1 and V3 is 3. Why? Because V1 has 3 edges incident on it. If this is vertex V1, then there are 3 edges E5, E4 and E3 which are incident on V1. Hence, the degree of V1 is 3. Similarly, if we look at the vertex V3, there are again 3 edges incident on it. V3 has edge E4, edge E5 and edge E6 incident on it. Hence, the degree of V3 is 3. Now, if we calculate the degree of vertex V2, here we can see that V2 has 1, 2 and 3 edges incident on it. But then why have we written the degree of V2 as 4? Because in the definition itself I told you that self loop are counted twice. Since edge E1 is making a self loop, so it will be counted twice. So once for edge E3, once for edge E2 and twice for edge E1. So 2, 3, 4. Hence the degree of vertex V2 is 4. Now let's calculate the degree of vertex V5. For vertex V5, you can see this is my vertex V5. So this is the vertex V5. So the degree of vertex V5 is 1 because there is only one edge incident on this particular vertex, which is edge V7. Hence the degree of edge vertex V5 is 1 because it has only one edge incident on it, which is edge E7. So basically the number of edges that are incident with a vertex, or the number of edges which are associated with a vertex, are counted as the degree of that particular vertex, with self loop counted twice. The degree of a vertex is also sometimes referred to as its valency. That means if I say valency of a vertex, it is the same as the degree of a vertex. Now let's look at isolated vertices. What is an isolated vertex? A vertex having no edge incident on it is called an isolated vertex. So such a vertex which has no edge associated with it, or which has no edge incident on it, is known as an isolated vertex. Since an isolated vertex does not have any edge incident on it, it is quite obvious that the isolated since the isolated vertex does not have any edge associated with it, it is quite obvious that the degree of an isolated vertex is 0. Any isolated vertex will have 0 degree. Then pendant vertices. So a vertex of degree 1 is called a pendant vertex or an end vertex. So any such vertex which has a single edge incident on it and no more than one edge incident on it is known as a pendant vertex. And it is quite obvious, if there is only one edge associated or incident on a vertex, then the degree of that particular vertex is 1. For example, if I look at this particular graph, the degree of vertex V5 is 1 because there is only one edge E7 incident on it. Hence, I can say that V5 is a pendant vertex or an end vertex. Then we will see edges in series. Two adjacent edges are said to be in series if their common vertex is of degree 2. So, any two such adjacent edges whose common vertex is of degree 2 are called edges in series. Just to remind again, what are adjacent edges? As we just read that adjacent edges are those non-parallel edges which have any one vertex is common, a vertex in common. So that means edges in series means any such two non-parallel edges with a common vertex, and then the degree of that common vertex is 2, then those edges are said to be edges in series. We will see through this graph all these examples. Now here you can see there is a graph containing isolated vertices, there is a graph containing edges in series, and there is a graph containing pendant and isolated vertex. So let's find out all these kind of vertices in this graph. Now if I talk of a pendant vertex, that means a vertex of degree 1 which has only one edge incident on it, then I can clearly see that V3 is a pendant vertex because V3 has one edge incident on it. It is having degree 1, hence I can say V3 is a pendant vertex. Now if I talk of isolated vertices, as I said, a vertex which does not have any edge incident on it and hence has degree 0 are called isolated vertices. So I can clearly see that V7 and V4 are such two vertices which do not have any edge incident on them. Hence I can say that vertex V7 and V4 are isolated vertices. Similarly, if I'll try to find out the adjacent edges over here, then I can clearly see that these two edges which are incident on vertex V1 are adjacent edges. First of all, they are non-parallel edges and then they have the vertex V1 in common. So they are adjacent edges. Then these adjacent edges having a common vertex V1 between them is such a vertex which is having a degree 2. You can see there are two edges, only two edges incident on V1, hence it is having degree 2. So these two edges which are adjacent to each other because of a common vertex V1 are known as edges in series because their common vertex is having degree 2. So we have easily found out the isolated vertices over here. We have found pendant vertex over here and we have found our edges in series in this graph. Now let's look at a null graph. So if we go by the definition of a null graph, a graph G which is equal to VE. That means a graph G which is a set of V and E where V represents all the vertices of the graph and E represents all the edges of the graph. It is possible for the edge set E to be empty. It is possible that there are no edges in this graph, that the edge set E is empty. So such a graph without any edges is called a null graph. So whenever you find such a graph which has only vertices and no edges in it, then you can call that graph as a null graph. Obviously, since there are no edges in a null graph, that means there are no edges incident on any of the vertices of the null graph. Hence, every vertex in a null graph is an isolated vertex. A null graph of 6 vertices is shown in this figure. As you can see, there are in total 6 vertices: V1, V2, V3, V4, V5, V6. So I can say that this is a null graph of 6 vertices because it has 6 vertices but no edges. Hence the edge set of this graph is empty. So I can call it to be a null graph. Although the edge set E of a graph G may be empty, but the vertex set V must be non-empty. That means you can have a graph without edges, but you can never have a graph without vertices. Otherwise, there is no graph at all. So that means the graph must have at least one vertex.